Hello students, in the last video we had discussed some numericals on the thermodynamics. Today I am going to do more numericals on this chapter. Now we will see this question. An isothermal ideal gas undergoes compression. Here you see, while reading the question, you please mark each and every term. It is very important in thermodynamics chapter. What process is given, what is compression or expansion, everything we have to notice very minutely. Here you see from the beginning, an isothermal and ideal gas. These two things you have to see. Isothermal means here del T is equal to 0. Okay, del 2 is equal to 0 means from the thermodynamics law we know change in internal energy is equal to del U Q plus W. This is your first law of thermodynamics. Change in internal energy, heat, this is heat content and this is your W, work done. Clear? Now this is equal to ideal gas undergoes compression, and here the condition is here compression. Compression means work done on the system. Clear? And here del V is equal to del final minus del initial, and it is given your del final is equal to, it is 5 mq to 1 mq. So here 1 minus 5 mq. Clear? It is minus 4 mq. Clear? So del V is equal to del V, change in volume, is equal to minus 4 mq. Clear? Now this isothermal process means del T is equal to 0. So del U is also equal to 0. Okay, that means sum of Q plus W is equal to 0. So here W is equal to minus Q. Clear? Now let us see what is W. W is equal to minus P external into delta V volume. Clear? External pressure it has been given 4 Newton. Okay, this is given 4 Newton m minus 2. So here it is equal to minus 4 Newton m minus 2 into del V is equal to minus 4 mq. Clear? And here you see it will be cancelling, 4 into 4, this is your 16, and Newton meter is equal to minus m minus 2 m plus 3. So only m will be left. So Newton meter is equal to your joule. So here W is equal to 16 joule. Clear? So W is equal to minus Q means heat released. That's why it is given to the surroundings. That's why it is given your minus Q. Clear? And that heat released, it has been utilized to increase the temperature of aluminum. And question has been asked, how much temperature has been increased? And the heat capacity of aluminum has been given 24 joule per mole per Kelvin. That means aluminum 1 mole if you will take aluminum 1 mole, then 24 joule will be required. 24 joule will be required to increase the temperature by 1 Kelvin. Clear? And here how much heat has been released in your process? In your process 16 joule has been released. So 16 joule will increase the temperature by how much Kelvin? So here 16 joule will increase the temperature by 24 into 16 K. So it will be equal to 2 upon 3. So it is equal to 2 upon 3 K. Clear? So this is your answer. Clear? By this process 16 joule of energy will be released, and this released energy will be utilized to increase the temperature of aluminum. Okay, you have taken aluminum 1 mole. Clear? Heat capacity of aluminum has been given. So you can easily calculate how much energy, that means temperature will be increased. Next question. The difference between heat of reaction at constant pressure and constant volume. Okay. So it has been given at constant pressure and at constant volume, difference between the heat of reaction at constant pressure and constant volume. So here the difference between del H minus del U. Clear? This reaction has been given, okay, at constant volume. This is equal to, as you know, del H minus del U is equal to del N G RT. Clear? And for this reaction, what reaction is given? Here you see, benzene liquid has been taken, 2 mole of benzene, it is in the liquid form. Clear? And here 15 gas plus oxygen, it is gas. Okay, and this is gas. Clear? Del N means this is your mole difference in of the gaseous products. Clear? This is your gaseous products. So here 12 minus 15. If you will take del N is equal to you are getting minus 3. Okay, del N, you are getting del Ng in this reaction, you are getting minus 3. Clear? So del H minus del U will be equal to del Ng is equal to minus 3, okay, into RT. Clear? Now if you will put all these values, this N is equal to minus 3, this is in mole, you see, 3 mole. Clear? And R is equal to 8.314 joule per mole per Kelvin. This unit, all units you please see it. Then 298 Kelvin. Now if you see mole, this mole unit, this will be cancelled, K minus K, it will be cancelled, only joule will be left. Clear? So it is equal to minus 3, it is equal to minus 3 into 8.314, clear, into 298, this is in joule. Clear? Now question has been asked in kilojoule, that's why we will multiply into 10 to the power minus 3 to get it as kilojoule value. Clear? So this is equal to minus 3 into 8.314 into 298 into 10 to the power minus 3 in your, this is your kilojoule values. Okay, if you are going to solve this, you will get minus 7.43 kilojoule. Clear? So here your energy, this is your answer. Clear?